Here's a little model I made of Frying Pan Mountain and Little Mount Pisgah to illustrate the concept of the camera elevation really impacting what you see with regard to the perceived height of foreground and background mountains. So you see, as the camera moves up, Little Mount Pisgah appears to be taller than Frying Pan Mountain, and if you keep the camera level with the top of Frying Pan Mountain, then Little Mount Pisgah is obscured, and it would appear lower off to the side as it is in this shot. So you can see the camera moves up and it becomes visible, the camera moves down to level with Frying Pan and it's no longer visible. Even here when it's off to the side, it's clearly lower than Frying Pan Mountain, which is exactly as it appears in the video. The distance from camera to Frying Pan Mountain is just about 6 miles, and Frying Pan to Little Mount Pisgah is 3 miles, which is half. So if I were to raise the camera up 100 feet, it would cause Little Mount Pisgah to visually raise up half of that 100 feet, which would be 50 feet. Seeing as how it's only 30 feet lower than Frying Pan Mountain, it would appear to be taller. And it does not appear to be taller in the shot. It clearly appears to be lower, just exactly as it is. The same would apply if I were to, say, have the camera 60 feet higher than what I'm claiming. Then again, at that point, because Little Mount Pisgah is about 30 feet shorter than Frying Pan, it's going to appear to be level with Frying Pan, and in the shot, it appears clearly to be lower than Frying Pan Mountain. So I would say that the elevation that is being shown by the altimeter is accurate to within 10 feet. I feel very confident about that. Not only because of what I'm showing you here, but because I actually validated the accuracy of the altimeter many times. I did that at the Blue Ridge Parkway overlooks and all along the trails, checking it against the topo maps, and it was always very accurate. And I built this little camera platform to stabilize the shot, because on previous attempts in other trees, the shot was extremely shaky. Actually, the wind was blowing stronger on those other days. Luckily, on this day, the wind was milder. With the platform and less wind, the shot ended up being fairly stable. Here is the actual shot, and this is the shot, the one that I was trying to get the whole time. You can see here that the altimeter reads 5382. What we're going to do real quick is take a look at Frying Pan Mountain and Little Mount Pisgah before we continue with the shot. We'll go ahead and freeze it here. And you can see that Frying Pan Mountain, as I claimed previously, does appear taller than Little Mount Pisgah. We're going to zoom in on this, and you can see here that this horizontal line, Frying Pan Mountain, looks a little bit closer to it than Little Mount Pisgah. Now, of course, there are things that could cause this to look this way, and my claim could be incorrect. I could be out of level by 1 or 2 degrees. It's possible. And the elevations for all of these mountains, the more sites I go to look at elevations, the more numbers I get for these mountains. But they're always within 30 or 40 feet. Usually 30 feet, and occasionally they're off by 50 feet. So the elevations could be slightly different than what I'm reporting, but we're close. Everything's very close. And the elevation of the camera and the accuracy of the altimeter could be called into question. Maybe I wasn't at the exact elevation I say I was, but again, I know I was close. I have a great deal of confidence that I was within 10 feet of where I claim I was. But anyway, this right here, this shot does actually suggest that I was at that elevation. Little Mount Pisgah being 9 miles away, and Frying Pan being 6 miles away, if I was, say, 100 feet higher than what I claimed, then Little Mount Pisgah would appear higher, and it doesn't. At the very least, they're level, which clearly implies that I'm very close to the elevation that I claim I'm at. And as I said, there's not enough of a difference possible, or enough of an inaccuracy possible, in either the elevation of the camera, the elevations of the mountains, or how level the camera is, to account for the actual shot of Frying Pan Mountain compared to Graybeard Mountain, because it just does not make any sense. None of the explanations or reasons or justifications that I could come up with to explain it away actually do explain it away. I'm going to zoom back out, and we will continue with the shot shortly. So I'm just going to let this shot run for a while. I captured a lot of this video. None of it is great. My camera's fairly good. The stability of the little platform I made was okay. The tree was moving around a little bit. I was moving around a little bit. But it's clear. You can see what I intended to have you see. There's Frying Pan. To the left is Graybeard. To the left of that is Pinnacle. To the left of that is Bald Knob. And Graybeard and Bald Knob are basically about 5,400 feet in elevation, which is about the same as Frying Pan Mountain. But they're 34 miles back. Actually, I think Bald Knob is 36 miles back. In this shot, you just see no... There's the altimeter again. And one note on the altimeter is that, I checked it when I got back to base camp. Every single time it was accurate. I checked it when I got back on the trail. Every time it was accurate. So I don't have any reason to believe that it's inaccurate. I'm just trying to play devil's advocate here and look for what could possibly be wrong with this observation. This observation shows these mountains on a flat plain. Now, I don't know why that is. I mean, I can evaluate evidence and tell you that that's what the evidence says, and I don't see any evidence for refraction. Every single time I went up there trying to capture this evidence, the mountains were at the exact same position. They didn't raise up and lower down. Refraction wasn't moving them around. There was no, unless it was consistently moving them up or down the same way every single time. And every single day since that I've been up at Shining Rock, and I've probably gone there 12 or 15 times since, and I'm always looking over at those mountains. I have like a little line of sight that I can use to check, and the mountains are always exactly the same height. They don't move around. If refraction is occurring, it's the same refraction every single time, consistently, without fail. This shot I find to be completely bizarre. Do I believe that the Earth is flat? That's a big leap to make, a really big leap, to actually believe in a conspiracy theory of that size. It is craziness. But what am I supposed to do with this evidence? I don't really know. Honestly, I don't really know. But I felt compelled to make this video. I felt compelled to collect irrefutable evidence one way or the other, so I could end the internal debate I was having about it and answer the questions I was having regarding flat Earth, because I did find the debate interesting. What we're going to do is we're going to freeze the shot right here, and this is the shot that I was attempting to capture the whole entire time. And this is Frying Pan Mountain, as you already know. This is Graybeard. This is Pinnacle, which, as you can see, is roughly 250, 255 feet taller than Graybeard Mountain, and that's kind of the average of all the different sources. And then there's Bald Knob, which I haven't mentioned before, but we'll just take a quick look back at Peak Finder to confirm that Bald Knob is the peak we're looking at. So here's Frying Pan, here's Graybeard, and then here's Pinnacle, and here is Bald Knob. They show, I think, on this site, Bald Knob is, 15 feet higher than Graybeard? But again, I went with the averages of a lot of the other sites that I was looking at, topographic sites, and some of the other peak locating sites. Again, it's kind of irrelevant, because if I were to change the elevations 30 or 40 or 50 feet here and there, we still essentially get the same result of the observation. If Graybeard is 5395, Bald Knob is 5375, that again is an average. Graybeard is 34 miles from Frying Pan Mountain. Bald Knob is 36 miles from Frying Pan Mountain. If we put a horizontal line in here, you can see that the line barely touches Graybeard, and it's slightly above Bald Knob. Now maybe that's 100 feet or more, so that might not be, I might be slightly out of level, like I had mentioned previously. So what I wanted to do is show you that if I tilt the image and get Graybeard and Bald Knob to both touch the line, or just barely miss it here on Bald Knob, which would be really accurate, it really makes no difference. The line is hitting about the same place on Frying Pan Mountain. So what I'm going to do is just leave it the same. Furthermore, the other thing is that Bald Knob is actually 36 miles away, whereas Graybeard is 34 miles away. If I were to go to the Earth Curvature Calculator, you can see here that 36 miles away gives 864 feet of declination, whereas 34, as we already know, gives 770. 770 versus 864, well, that is 94 feet of extra declination. What that means is that Bald Knob on a curved Earth should actually appear a little bit lower. But as I said, I can tilt it either way, and it just doesn't make enough of a difference. So I would say we're within the margin of error everywhere here. So what I want to do is, first of all, point out the fact that Graybeard Mountain should be down 770 feet. Down this way, somewhere around in here. And it should appear lower than Frying Pan Mountain. And the fact that Bald Knob and Graybeard are essentially the same elevation, you can draw a horizontal line across them, and you're going to get a really accurate result. You're going to know that what you think you're looking at is what you're looking at. The camera's not tilted radically, giving the illusion of Frying Pan Mountain being lower. Frying Pan Mountain is lower, clearly, and it should be higher, visually speaking. Okay, so we're going to get rid of the horizontal line and Frying Pan Mountain and Graybeard. And we're going to leave Pinnacle and Bald Knob because they are roughly the same distance from the camera position, and the average difference in elevation between the two is 260 feet, which looks like this. So, that is 260 feet. And again, that is an average of the resources that I used for elevations. Some sites listed the difference at 280 feet. Other sites listed it as little as 240. I chose 260 as a nice median number. And again, I could change that number by 10 or 15 feet, and it's not going to have any sort of real impact on the final rendering. The outcome will basically be about the same. So 260 feet times 3 looks like this. So 1, 2, 3 is 780 feet, which is the approximate declination which should occur and is not present in this observation. So the declination we should be witnessing should be from here to there. So, in other words, let's get rid of all this now, and get rid of pinnacle and we'll put Graybeard back. So what we're going to do is we're going to take our scale reference for the declination that we should be observing and move it over to Graybeard Mountain. And then we're going to get rid of all of the lines but the bottom line, and this is roughly where the top of Graybeard Mountain should be. So this is our outline of our mountains. Then our mountains should actually be roughly down about here, not up here. So if we go by the mainstream accepted and taught curvature formula for the spherical surface of the Earth, then Graybeard Mountain should not even be visible. We shouldn't be able to see it. So, and maybe, as I've mentioned multiple times, the elevations are slightly off by 20, 30, 40 feet. And so maybe Graybeard should be right there. Or maybe I'm out of level with the camera, and Graybeard should be right here. But there's no possible way Graybeard should be right here. It should be there, roughly speaking. We should not be able to see it. So this is the conundrum, the paradox, the thing that I have tried to figure out ever since I collected this data. Why is Graybeard up here when it should be down here? Why is this entire mountain range up much higher than it should be? Frying Pan Mountain, Graybeard Mountain, and Bald Knob are all roughly the same elevation. But Graybeard Mountain and Bald Knob are 34 and 36 miles behind Frying Pan Mountain. So they should be massively declined out of view. And they're not. They actually look as though they're on a perfect level with Frying Pan Mountain, which is only possible if the surface they are protruding from is level, unless somebody else can offer me some other explanation. So that's my video, and that's the evidence I present. I welcome anyone to explain this to me in a way that makes sense as to why these mountains appear essentially level with one another, and explain to me why there is zero curvature recorded in this observation. The only explanation I can come up with is that the surface they're protruding from is flat and not curved. But if there is another explanation and someone could offer it to me and it makes sense, I am perfectly willing to accept it. So thank you for watching my video. You can leave comments or write me an email if you'd like, and I will definitely get back to you. As I said, anyone who can explain this to me in a rational, logical way, I would greatly appreciate it, because I have spent many hours trying to explain this to myself, trying to find a reason other than the Earth is flat for this observation, and I've yet to find it. Thank you.